Hi, my name is Patrick Schick. Hello and welcome to the IDS Vision Channel session talking about our UI+, XCP and XLE cameras. In the talk, we will discuss how you can make the best use of your UI+, XCP and XLE camera. And furthermore, we will not only discuss, we will show you in practical examples how to use and program the UI+, XCP and XLE cameras. So stay tuned. But before we start with the topic, let's do a short recap and summarize the last sessions. For those of you who didn't watch the session where we introduced the UI+, XCP and XLE camera, watch here on the IDS Vision channel and look for the video What makes the UI+, XCP and XLE camera special. But let's summarize. Within those two camera families, It's So Easy and Reduced to the Max perfectly came together. Small and budget-friendly cameras, supplemented by perfect fit accessories and powered by the IDS Peak software development kit. Together, it creates a package to desire nearly all your machine vision needs. So short, so far? Let's get practical and set up a camera for image acquisition. Okay, here we have all necessary parts to build up a camera, to connect the camera and let them run on a PC and develop the first programs. So we start with taking the camera, putting up the front cap, screwing on a lens, a fitting IDS branded lens on it. We fit the tripod adapter, which is also an accessory for this camera, to it. Just give it a short second. And last but not least, we take our budget USB cable, connect it to the camera, to the PC, and now we're ready to start for image acquisition. So let's get and have a first look on the Vision Cockpit. So here we directly jumped into the IDS Peak Cockpit. And now let's see what we can do within the IDS Peak Cockpit. By the way, if you want to get a closer look into the IDS Peak Cockpit and its features, have a look at the UI+ cluster session in November, Configure Not Program, here at the IDS Vision channel. The IDS Peak Cockpit gives you a lot of possibilities to parameterize your camera perfectly. In the first intention, it visualizes a nice looking image. But you could set up the camera as your application desires. I will go deeper into two specific topics, and this works together with the color feature. Because the UI+, XCP and XLE cameras do not have color pre-processing on camera, so here you can see we have as a source pixel format a rare Bayer, and the destination pixel format in the IDS Vision Cockpit is set to a debayered format. So if I set this also to the source format, you could directly see this would be the raw image the camera provides you. And so here on the Vision Cockpit, as told before, you have a lot of possibilities to do pre-processing tasks which are done on camera directly here on the host. Let's say, have a closer look to here. We have the auto features, auto exposure, auto gain, all available and runnable here. You can see it here we have the host features. So within the cockpit, you can completely set up the camera, then store the parameters in a parameter set and reopen it in your own application. So this was really a quite short look on the IDSP cockpit, only to show you the abilities which are included there so that you can set up your camera without any programming. And let me dig a little bit deeper into the topic I discussed. There is this on-camera and on-host processing. So in general, we distinguish between on-camera processing and on-host processing. IDS cameras like DJI CP, SE, and FA, including a technical component, the so-called FPGA, on the camera, which gives these cameras the ability to do some simple processing tasks on camera. For example, debuyer. Debuyer means that out of the color filter array on the single pixels, a RGB color image gets calculated. If you do this on camera, you relieve the CPU on the host system. But as you can see here on the image, we have the sensor, then we see that the FPGA does the debuyying. This increases the amount of data, because per each pixel, 3 times an 8-bit value per pixel is required to transport the data to the host system. And therefore, you increase the bandwidth usage. As on all our FPGA-based cameras, you can decide if you want to do pre-processing on host or on camera. So you can set up your system as your application desires. But to have this choice, as told before, an FPGA is required, which means additional electronic components and therefore higher costs, bigger cameras, more heat dissipation, and so on. If you're looking for a space-saving, budget-friendly camera, then less is more. And for example, one component which is not necessarily required is the FPGA. Because all tasks a FPGA does on camera can also be done on the host system. The UI+ XTP and XLE cameras, for example, are such space and cost-saving cameras. So, as shown with the IDS Vision Cockpit, if you require color processing here, it has to be done on the host. Right at the moment we are talking about color processing, so if you are working with a mono camera and think this is not of interest, then you have to be aware that similar is valid for auto features like auto white balance, auto exposure, auto gain. Also here you can decide, would you do it on camera or on host? How this is influenced, we will have a closer look soon. Okay, back to the topic. As the UI+ XTP and XLE does not include a FPGA, color pre-processing has to be done on the host, which also brings its benefits with. One major benefit is the less bandwidth usage, because only 8 bits per pixel are required here, and often, especially on budget systems, bandwidth is rare. But CPU power is available. On the other hand, you can reuse your own debuyer algorithm. Especially suitable when your machine vision application depends on the results of this specific debuyer algorithm. This brings us shortly back to the point of auto features. Auto features on camera profit from short cycle times and are independent from the calculation power of your host system. But as told before, if you depend on your own algorithm and calculation power is not a topic, then you're able and free to calculate by your own. But enough theory, let's get practical again. In 3 samples, I would like to show you how easy the integration and usage of the host algorithms are. At first, we will integrate and use the camera in Helken, the machine vision software from MVTech. Then, in a second step, I show you how to implement this in Python and with all the free available Python tools. And last but not least, I will give an example with the IDS Peak Comfort C SDK. For the usage of an IDS camera in Helken, no additional software is required. Just use the MVTech USB 3 Vision transport layer and start working. If you would like to go more into the usage of IDS UI Plus cameras and Helken, just check out our IDS Vision Channel video, Easy UI Plus Camera Integration in Helken. To make life easy, we use the Image Acquisition Assistant and grab a live image. It should be a quick example how easy and fast it is to use an UI Plus XCP and XLE camera with MVTech Helken to get a nice color image. You just only have to write one single line of code by yourself. Here we're in Helken, the GUI is still opened, and we use the image acquisition tool, open a new image acquisition, and use here the USB 3 Vision connection, choose the IDS camera. Then we click easily on code generation, insert code, and here we are. So let's do the example step by step. We open the frame grabber, grab an image, and here you can see in the screen we grabbed a raw bio image. So for the next step we use the so-called CFA to RGB, where, as you can see, auto-completion helps us. We use the image, which we get from the camera, we store it in RGB image, and then acquire image, and as you can see, we get a nice RGB image. As told, a single line of code into Helken, acquire a raw image from the camera, and you get directly out an RGB image. Okay, this was the short example how to get also nice colored image with IDS, XCP and XLE cameras inside of Helken using the host features to get a color image. Okay, next. It's not always possible to have a software like Helken from MVTech on hand, or a bit of machine vision rapid prototyping Python comes handy to test your solution. Also here I will give you a short glance of using the color features. If you'd like to know more, have a closer look at the IDS Vision Channel video, Rapid Prototyping Camera Applications. But for now, let us dig in the code here. To visualize the necessary code snippets, I will use Jupyter Notebook, and the code is reduced to the necessary color features, which comes with the IDS Image Processing Library, the so-called IPL. So here we are in the Jupyter Notebook, and I would like to show you color conversion with the IDS Peak Image Processing Library. So first of all, for sure we have to initialize all the code, so we have to import IDS Peak and the IDS Peak IPL, and as told before, a helper class which supports us during this sample. So we initialize the IDS Peak library, and then we get the first available camera. As only one camera is connected, we can do this easily. So as you can see here, we have a USB 3 Vision XCP camera connected. We will open the camera and we'll check the available pixel formats. Also here we see it's only the only format is a raw Bayer image. So now we know we have to calculate a real RGB image out of it. Let's acquire a single image from the camera. So to display this, also the helper helps us, and we display here the image as it comes from the camera. You can also see that we acquire here a raw color image. And now, again here, also when using the IPL, the IDS Imaging Processing Library, the only thing you have to write, convert the image into an RGB 8-bit image. We have an IDS IPL image now on hand, and this image itself includes a method which converts the pixel format into the one you would like to have, in our case an RGB 8. So let's do this. Convert and display. And here we are. Again, we have a nicely calculated color image with one single line of code. Also in this example, you can see it's totally easy. If your camera does not support on-camera color preprocessing, you can easily use the host system to do the color preprocessing. And last but not least, we'll have a closer look to our IDS-P Comfort C API. Also here you will find a video on the IDS Vision channel which digs deeper into interfacing UI+ cameras. Now I will focus on the IPL features, which gives you on the host side easy access to a bunch of auto features. As base, I use the SimpleLife Qt widget sample, which is included in the IDS SDK installation. How you get there? Just go to your IDS Peak folder. There you see the Comfort C sample source code. If you click on this, a folder opens up where the sample code for a SimpleLife Qt widget sample is included. And I used this example to program, for example, the auto white balance features, which I will show you now directly in code. In this SDK, majorly I would like to show you one feature as an example, because in the IDS-P Comfort C API, a lot of convenience methods are implemented so that it is not necessary that you program every single GennyCam call to do, for example, an auto white balance. In the IDS-P Comfort C API, we integrated, as you can see here, a method, auto white balance mode, which does all the necessary tasks for you. And here also the thing to know is that you can implement this either on camera, or as we would see here, you can implement this on host. On host, it is always when we implement it in the IPL, in the IDS Image Processing Library. So the only call you have to do, here we check if a feature is accessible on camera. If not, we switch to the IDS Image Processing Library and set the mode on host. That's the only line of code you have to write to do an auto white balance. So I will start the code now and you will see how it's worked. Don't be afraid the first image to get a good example. I make a really bad white balance now because we want to do this automatically via the host. So start the application. Some compiling goes on, and here we see the image. We reduce a little bit the exposure, and then I press here the white button and get a really good white balance image. So also via the IDS-P Comfort Z API, there are a lot of on-host features which you can use to perfectly set up your UI+, XCP and XLE cameras. And with these 3 short examples, I would like to come to a short summary. Comfort image processing features from color calculation up to auto features like auto white balance or auto exposure do not necessarily require on-camera processing. Especially when it comes to budget and high-volume projects, your application profits from the cost-saving IDS UI+, XCP and XLE cameras and the possibilities to use the processing power of your host system. If you like to get further information about the IDS UI+, XCP and XLE cameras, have a look on our website or contact your sales responsible. Hope you have enjoyed this session and start using the UI+, XCP, XLE cameras. Thanks for watching. Goodbye.